All right, this is our second video for section 6.6, and here we're just going to focus on taking the graph of a function and writing the equation for it in terms of both the sine and cosine function, okay? It's important to understand that now that we've covered horizontal translations for our two trig functions, that a sine function can be written as a cosine function if you just take a horizontal shift into account, and it works in the other direction as well, okay? Now, in order to write your equations, you have to identify some key characteristics of the function first from its graph. Okay, so first thing I'm going to look at is the midline of this curve, which is right here at y equals 1. And the reason I want to identify that first is it helps me see that the amplitude is 2 units, the distance from that midline to any of the high or low points on the curve. Okay. And then the next thing I'll identify is the period. Notice that if I start right here on the midline and move along the curve, I'm going to get the pattern to repeat after 120 degrees. So period here is 120. And the period leads me to the b value associated with my equation for the function. Okay, so the b value will always equal the normal period for a sine or cosine function of 360 degrees divided by the actual period of the function you're working with, which will give me a b value of 3. Okay, so let's come up with a couple sine equations for this function first. To determine a sine equation, you have to pick a point from the curve that's on the midline itself, okay, right? Because think about the parent function for sine. The first point that we plot, first critical point, is at the origin, right? So for this particular curve, I could choose this point right here at 0, 1 to start my cycle, okay? And if I choose that point, I don't have to account for any horizontal shift taking place, okay? Since the x value of that's at 0 still. Now, the equation will have to start as y equals, or f of x equals, and you would need a -2 for your a value. And the reason it would need to be negative is because from the green point, if you move to the right on the curve, you're going to have to be heading downward first, okay? Then you're going to multiply that -2 by the sine of your b value of 3 times x. And then you have to finally account for a vertical shift 1 unit up, so add 1 into the equation, all right? Now, suppose you didn't choose that green point as your first point of a cycle, and instead you chose, let's say, maybe this point right here at -61, all right? Now you would have to account for a horizontal shift of 60 degrees to the left of the y-axis, right? So that changes a couple things about the equation. Now your a value would have to be considered +2. That's because from the purple point, as you move to the right on the curve, you'd be heading upward first. You're going to multiply that by sine of, and here's where you'd have to account for the horizontal shift. You got to take your b value of 3 and multiply that by the quantity of x plus 60 degrees. Okay? That gives you the shift 60 degrees to the left. And then add on 1 at the end for the vertical shift 1 unit up. Okay? Now those are only two equations for the sine function in terms of the sine function for this curve. But understand you could have chosen any of the other points on the curve that are at the midline to develop your function as well. Now let's do this in terms of the cosine function, okay? For a cosine function, you want to pick a point that's either a high point or a low point on the curve. So let's say we choose this point right here at -30, 3, okay? Notice that that point starts above the midline, and also that it's 30 degrees to the left of the y-axis, okay? So based off of that, I'm going to say that y should equal positive 2, since you're above the midline, times cosine of 3 multiplied by the quantity of x plus 30 degrees, and then add 1 at the end, okay? Maybe instead of choosing that orange point, you chose this yellow point down at that's positive 30 comma negative 1. That's below the midline, and it's 30 degrees to the right of the y-axis. So how does that change the equation? Well, now it's going to have to be y equals negative 2 times cosine of 3 multiplied by the quantity of x minus 30 degrees. That'll give you the shift of 30 degrees to the right, and then plus 1 at the end. Okay.